Greetings everyone, welcome to today's video. For today's video, we'll be dealing with coordinate geometry and specifically practice questions. We already covered coordinate geometry in our previous video, so just practice questions for today's video. And if you're not familiar with any of the concepts that we'll be dealing with in today's video, please make sure you watch the video that was posted before this on coordinate geometry. If you're unable to find it, you can navigate your way towards the ISP channel, that's International Scholars Program channel. Under the playlist, go to the Quant GMAT playlist and look for coordinate geometry concepts. And so, without much further ado, let's get into the practice questions. Here's a practice question. If you can do it, if you will do it, please pause the video and give it a try. In the meantime, I'll talk about what we covered in the previous video. We did look at what points are on the coordinate geometry and where they fall. We talked about the quadrants. We talked about the forms of the equations. We talked about what are gradients and what are y-intercepts. Then we did a few questions and then talked about the quadratic equation and what happens to the properties of these quadratic equations. Besides that, we finally looked at the reflections on lines on the quadratic, not quadratic, but the Cartesian plane. The common lines, y is equals to x, y is equals to negative x equals to 0, and y equals to 0. And so, let's get into the question. In the figure above, the coordinates of point V are, this is among the first slides, so let's figure out the coordinates of V. And the coordinates, we usually write them as x, comma, y. We find the x value, then find the y value, then combine them, as in the answer choices. So, what's the x value? On the x-axis, it falls under this x point here, and it's 1, 2, 3, 4, 5, 6, 7. So x is 7. What about y? On this y-axis, it falls below 0, so it should be negative. And therefore, if the y-axis doesn't have any negative value, you can easily eliminate it. You don't have to find the actual value. And you can figure out that is the answer. But let's figure out if it's negative 5 for the value of y. So for the value of y, v it is this point here. That's 1, 2, 3, 4, 5. And that's negative 5. Therefore, x, comma, y will be 7, negative 5. Answer choice E. Let's go on to the next question. So in the xy plane, what is the slope of the line with equation 3x plus 7y equals to 9? What's the slope? Now it's playing around with the form of the equations. This one thing we covered. To restructure this, we have 7y equals to 9 minus 3x. Y doesn't have to have a constant, so we have to divide each and every term of this equation by 7. This gives us y equals to 9 over 7 minus 3 over 7x. So looking at the gradient, it's negative 3x, which is answer choice B. In a coordinate system, P equals to 2, 7, Q is equals to 2, 3, which could be the coordinates of R if PQR is an isosceles triangle. So what's an isosceles triangle? An isosceles triangle is a triangle whereby two sides are equal. Yeah, can be. Either of these two sides can have of these three triangles. So let's look at this. 12, negative 3, negative 6, negative 9, negative 117, 2. Okay, you can give the question a try. Pause the video. Okay, looking at the question, let's try visualize. Yeah, try visualize. So point P is 2, somewhere there. Let's have it somewhere there. That's point P. Then point Q is 2 along the same 2, then negative 3. So negative 3 somewhere here. So the point Q is here. So they're on the same line. Suppose we bisect this line by 2. Whatever point that falls on that bisector line will form an isosceles triangle. Okay, so any point on this line, let's bisect this line. The line moves from negative 3 to 7. How many steps are those? 3 to 0 and 7 to P. That's 10 steps. So to bisect this line, the steps needs to move from 7 minus 5, that's 2. So the point that falls on this line, 2. If you compare the distance, it will be 5. 7 to 5, 2 is 5, and 2 to negative 3, also 5. So whatever point that falls on this line whereby y equals to 2 will form an isosceles triangle. And that's an example of this 3. Okay, so negative 117 and 2 will form an isosceles triangle. Expect 117 to be very far away, so somewhere closely, some point like that. Okay, so that's a possibility. So 3 could be possible. Okay, right. So let's go on. And this is what we've covered here. Let's erase this slide. And now think about the formula. Now let's think about the formula. Distance. We said this could be possible. So any answer without 3, B is out and A is out. So let's figure out C, D, and E. So we said distance of between 2 points will be the square root of take x2 minus x1, then add y2 minus y1. That means if we are to have the triangle, this is PQR, and P is 2, 7, Q is 2, negative 3. So let's figure out the distance of PQ. The distance of PQ will be then negative 3 minus 7, that's negative 10. Negative 10, sorry, this is squared. So negative 10 squared is 100. So this gives you 100 plus 2 minus 2, that's 0. 0 squared is 0. So this is 0 square root, that will be 10. So distance between P and Q is 10. Okay, now let's figure out 12, negative 3. Suppose you had 12, negative 3. The distance between P and R will be negative 3 minus 7, that's 10. 10 squared, that's 100, plus, keep all this square root. Then 12 minus 2, that's 100 also. So this should give it 200 square root. That's not equal to 10. So can't be equal to PQ. Now let's try QR. QR then will be negative 3 minus 3, that's 0. 12 minus 2, that's 10. 10 squared is 100, square root is 10. So for that case, QR will be equal to PQ. And then form an isosceles triangle. So that could also be possible. Okay, so let's try again. The last point, that's negative 6, negative 9, negative 6, negative 9. So PR will be negative 9 minus 7, that is negative 9 minus 7, negative 16. Squared plus negative 6 minus 2, negative 8 squared, this is 64, square root. Doesn't make sense. So let's try QR. QR then will be negative 3 minus 3. That's negative 9 plus 3, negative 6. Negative 6 squared, that's 36, plus negative 6 minus 2, that's negative 8 squared, that's 64 squared. This should give you 100, and therefore this is 10. So QR will be equal to QP again. So this could also be possible. So 1, 2, and 3 could be possible. So our answer is A. The moment we found 1 was possible, then D was out. We left with C and A. We confirmed 2 was possible, so 1, 2, and 3 are possible. That answer is E.
You are watching Success with Bob Mwiti Show, presented to you by the International Scholars Program. The International Scholars Program is an award-winning international education financing scheme that helps bright students to pursue graduate studies abroad regardless of their financial background. You can find our programs by going to www.internationalscholarsprogram.com. The International Scholars Program, empowering dreams.
Okay, let's move ahead. Now, this is a parabola or a quadratic equation. We're told the equation above, that's y is equals to ax squared plus bx plus c, represent a parabola in the xy plane if a is less than 0. We talked about that particular property. If a is less than 0, the parabola opens downwards. And the x-intercepts of the parabola are -1 and 3. Which of the following could be the vertex of the parabola? The vertex being this optimal point. Okay, so let's give it a try. Right, so we talked about the parabola. And one unique thing about the parabola, if you take a point, bisecting the gradient of this parabola, whereby we have the vertex, if you take the gradient of that, this line here is usually equidistant from every point on. It's like a mirror. If you take a point here and maybe mirror it on the other side, you'll have a point on the same quadratic equation or quadratic parabola or the parabola itself. Okay, so it's equidistant from one point to this other point. Just basically symmetrically cuts the parabola. So then, if you have x-intercepts, talked about this and this, so we have -1 here and 3 about there. So then we're told this parabola goes up, then comes down, intercepts x at -1 and 3. So we're told which of the following could be the vertex. This optimal point could be the vertex of the parabola. So let's bisect this point. So distance from 3 to this point here on the x-axis is equal to the distance from -1 to this point. So to find the midpoint then, we find the distance. The distance between 3 and -1 is 4. So 2 steps from -1 should get you to 1. And 2 steps from 1 to 3 should get you from 2 steps from 1 should get you to 3. Okay, so we expect then the parabola, the vertex of the parabola to go through this point 1 and have x equals to 1. So for that case, A is out, C is out, and E is out. Okay, then let's observe we said the parabola opens downwards. So we expect then the vertex to not be negative, instead should be positive. That's the value for y. Shouldn't be negative, should be positive. And for that case, we conclude then D is our answer, because point B will be below the x-axis. Right. I hope everything's perfect. Let's go on to the next question. It is line P has a positive slope and a positive y-intercept. Line Q also has a positive slope and a positive y-intercept. The two slopes and the two y-intercepts are 4 different numbers. none equal. Lines B and Q have a single intersection point. What is the full set of possible quadrants in which the intersection point could be? Okay, so let's have fun here. We have the Y and have the X. We said the line with the positive slope increases, okay, can be just fairly raised or very steep. Okay, so it depends on the gradient of the line. But we're told it only has a positive slope and a positive y-intercept. So the line can never go through this area here going downwards. It needs to go through positive values of y. So these lines then can intersect maybe in, say, let's try to draw this once again. Let's list the possibilities. So we could have maybe have it intersecting and have line going there and maybe another one going there increasing. Sorry, let's have that point here. So yeah, something like that. So this shows that these lines can intersect at the third quadrant. You can also have a situation whereby let's have them intersect at the second quadrant. Okay, this is possible also. So second quadrant, perfect. What about the first quadrant? For the first quadrant, you can have maybe going that way and one from this end meeting. Okay, this is another quadrant. That's first quadrant. What about then the fourth quadrant? If we look at the fourth quadrant, for any line to intersect the fourth quadrant, it needs to pass through the negative y values. Okay, and if it has a positive slope, okay, unless you have a negative slope, then you can think about going through the positive y-intercept and that particular point on the fourth quadrant. But since we're told also the lines needs to be positive, then we need them to go through a positive y-intercept. And for that case, this can't be possible. The only possible quadrants are 1, 2, and 3. That's D. Next question. Pause the video, give it a try. In the coordinate plane, line K passes through the origin and has a slope of 2. If points 3, y, and x, 4 are on line K, then x plus y equals. Okay, so we need to find the x and y. So possible way, we have the origin here. Origin is point 0, 0. That's origin. So we can use the origin to find for the unique values of x and y. Then find x plus y. So how do you find the slope? Slope is change in y over change in x. For that case, let's take point 3, y. So y minus 0, that's the origin, over change in x. X is 3 minus 0. That's has a slope of 2. If you do the same for this other point, then change in y over change in x equals to 2, slope of 2. So if you solve for this, this is y equals to 6. And this will be x minus 0, that's x. Then 4 minus 0, that's 4, equals to 2x, which means x is 2. So y is equals to 6, x equals to 2. Then x plus y, you expect that to be 8. C. Okay. Next question. Pause the video, give it a try. We have the point going through 0, 2, and the x point going through -3, 0. So to find this, 0 is minus 2, or 3 minus 3. -3 minus 0, that's -2 over -3, that's 2 over 3 as the gradient. So which of these other lines can have the same gradient? Notice the form. We have to manipulate the form mentally so that you can see if we have the same gradient. If you take 2x on this other side, you'll have 3y minus 2x, which is equals to 3x, sorry. That gives you y equals to 3 over 3x. Yes, same gradient. If you take the other way around, it will be negative 2. So the gradient will be negative. That's not parallel. We have to have the gradient of line 1 equal to gradient of line 2. Gradient of line 1 equals to the gradient of line 2. So B is not possible. If you try C, then you have negative 2x also, and you have to divide, so the gradient will be negative, not possible. If you check D, you'll have 3 on the other side, it should be positive 3, and this one will be 3 over 2, which is not equal to 2 over 3. So you're close, positive, but not the answer. Then for 2y equals to 3x, this becomes negative 3x, so negative 3 over 2, the gradient is not equal to 2 over 3, and it's negative also. Eliminate. So the only line that has the same gradient or parallel to our line here is line A, which is 3y minus 2x equals to 0. Okay, I hope that's clear. So that brings us to the end of the session. It's been a fast-paced session. I hope you guys have learned a lot from this session. In case you have any recommendations for the future videos, please let us know so that we can post your recommendations. Have a great evening. Have a great day ahead. Bye-bye.